Okay, we're back at this spreadsheet and we need to know what to do with these recently calculated ratios and all of these averages that we did. What goes on? How do we get a graph? How do we solve for the unknown concentrations? All these questions are out in the open and we still haven't made it all the way to the end of these videos. Okay, so here we go. This is how this graph is going to be generated. Before we make this actually raw cal curve, IS cal curve over on the right hand side, we have to focus on the remaining column that is left. And that remaining column is right here, and it's called the true concentration. So this is, what are the concentrations of these standards that you made based on the alcohol that you used in the standard prep? So keep in mind, this is for 2024 batches, which you do not have. This is not the data. This is not the data. You cannot use these numbers. You've got to go by what you did, by what we did as a group in all of the standard and the sample preparation. Based on 2024 data, they took 4 mils, they diluted it to 25, and then they took 20 milliliters of that and went to 250. That's what happened. Maybe not what we did in the video. Maybe it was, maybe it wasn't. You got to watch the video to find out. Either way, this first one was made to give us a concentration of 12.62. And then 20 mils of that was diluted again to 250. And we got a concentration of 1.01. Keep in mind, this was CV equals CV. That is how we got that value. We talked about it in a different video. So whatever concentration this is, you are going to see that concentration be auto-populated in part B of the table. Because it's that standard that we use to make everything else with. That's how this worked. All right, well, in the standard prep, we took 50 milliliters of that standard concentration and we diluted it to a total of 100 mils. At least that's what the batch of 2024 did. Did we dilute to 100 mils? You got to go back and watch the videos to find out. You got to key that in if you didn't. So 1.01 is our magic number. That's our magic concentration, right? So 1.01 is the concentration of what we called the working standard. This made all of the other standards that we used in the headspace system. So what this means is that we took 1.01, because that is my CV equals CV. And in the standard 6, we took 50 milliliters of that stuff. We want to know what is the new concentration if I diluted to 100 milliliters in total. So this is just a dilution problem. All of these will be dilution problem. Again, very similar to the one before. This is my initial concentration, though, for all of them. That's why they're all the way down. These are the volumes that we used to make those standards with: 50, 35, 20, 10, 5, and 2. And we took that to volume in a 100 ml volumetric flask based on this standard prep. Was ours the same? Again, go back and watch. It will tell you. So we need to calculate the true concentration of these standards that were prepared. And that's how we do it. So if I bring in our little calculator, and I'll just do this over on the side, I'm going to take 1.01 times 50, and then that's x times 100. So we got to do the opposite of, we got to divide, not multiply. We divide by 100. That way we can get x by itself. And when we do that, the concentration is 0.505. All right. So that is the value that's going to go here for the true x. All right, so let me clean this up a little bit, because we want Excel to do this for us. We don't want to type it in. And I want to continue that trend all the way down, because we've got 6 standards that we've got to calculate. So in this cell that says the true concentration, I'm going to type in equal. I'm going to open the parentheses up. We took 1.01, that's my concentration, and we took 50 mils of that. We multiplied those together, kept them together on the same step, and then we divided by the final volume, which was 100. Again, it is a dilution. So I hit enter, and there is the true concentration of that standard, number 6, that we analyzed on the GC Headspace system. Keep in mind, the standard for legal limit is 0.08 in North Carolina. This is 0.5. Now, I hope that no one's going to be 0.5. If so, they're going to be in the hospital. But we've got to go higher than 0.08, and we got to go lower than 0.08. I mean, that's the only way that this makes sense. Because if that's what we're trying to determine, that's the range that we want to kind of dance around in. All right, so I'm going to do the same thing for standard number 5. So I hit equal. I'll open my parentheses up. I took that concentration again, and this time I delivered 35 milliliters of that stuff. So I closed the parentheses off, and then I'm going to divide by the total volume, which is going to be a 100. CV equals CV. I hit enter, and there is another now concentration that we analyzed. I do this all over. I take my concentration, and we took 20 mils that time of it, and then we took it to a total volume of 100. I took that same stuff. This time I only did 10 mils of it, and then I took it to 100. Once more, I'll repeat this stuff. I took 5 mils this time and diluted to a total of 100. Now we're on the range of 0.08, so we're now below that. Same deal, took that concentration, took that volume, and divide by 100. All right, so here are the concentrations that we have calculated for our standards. And of course, the concentration for my blank is 0. So I can add 0 into the mix. And there we go. Now I'm going to delete this just for a second. All right. So if you've taken other classes before with us, you have maybe been exposed to a calibration curve. What is a calibration curve? How do we handle it? What does it do? And to plot a calibration curve, most of the time on the x-axis, when we plot these, on the x-axis, it is always the concentration of whatever we are doing. This time it is in percentage. but it could be in molarity concentrations, part per million concentrations, percent by volume, percent by weight. I mean, the list just goes on and on and on. There's so many different ways to report concentrations in laboratory procedures that x-axis can be multiple different units. But overall, general speaking, that x-axis needs to be your concentration. All right. And then up until this point, most of the time when you did calibration curves, if you've done those in other classes, your signals would go here on the y-axis. Now, those signals are called signals because they're from the reports, they're from the machine. And in this particular case, this is actually from the area because that's the signal that the machine is seeing. It's calculating areas under those peaks. Area is what's reported on the report down there at that table. So therefore, area is the raw number that gets plotted on the y-axis. So if you look at this calibration curve right here, this looks pretty darn good, right? I mean, here we get the x-axis all the way across, and we get this y-axis up and down. I mean, that looks really, really good. All of these points are in a straight line, with the exception of maybe one. It's slightly off. It's not a big deal. But all in all, I think this looks really good. If you did this on your own, I would be like, excellent job! You got an R squared of 1.00. Woohoo! Good! And what's even more exciting about this is that multiple people actually, when this batch was ran, multiple people made the standards, and they all shared the duties. So one person made one or two, another person made one or two, another person made one or two, and they all ended up, except for one, because one of the duplicates did not make any sense, but overall they all ended up pretty good. So when we do this raw calibration curve, what you are seeing with the raw calibration curve is that this is actually going to be plotted with your concentration. I've highlighted the data. It's your concentration on the x-axis and your average of the ethanols as far as area goes on the y-axis. So what I did is that I held down the control button and I just clicked these values that I wanted plotted, and it knew that those probably needed to stay together, and then it plotted this regression line. If you need help with that, because maybe this is not in the report and you've never done that before, I'll get rid of it. So what we'll do is that I'll hold down control. I'll click on 0.5 and then 1340, 3535, 9305. Hold the control button down the entire time. 2020, 4700, 1010, 2476, 05, 1173, 02, 528, 0, and 0. Now I release the control button. All right. By holding the control down, you can select more than one thing, right? They don't have to be adjacent cells. You can click and pick and do whatever you want to do. Once those get highlighted, at the very top of this Excel spreadsheet, and I'm going to drag this out just a little bit so you can see it. At the very top of this Excel spreadsheet, there is going to be an insert function, and we are going to insert. So I'm going to click that, and we're going to go over to the scatter plot area, and I'm going to click that arrow. And then I'm going to come down and I'm going to click this option that's just points. That's all that I'm going to do. Now it says some chart types cannot be combined with other chart types. Select a different type. Okay, well, let's just try this again. I'm going to show you a trick here. So I'm going to highlight the data just like he told me to do 5 minutes ago. And then insert, scatter, plot. Nah, sorry. Oh no, what on earth am I going to do? So this is one of the reasons that I wanted to show you this method of Excel work, making a cal curve, because up until this point, a lot of your data has been side by side if you've done this before. And the only thing that you had to do was like click and drag over. That was it. That no more than that. All right, well, what would happen if this is the case? What if I held down Control and highlight this entire column, and then highlight this entire column, and then let the control go? I want X to be my concentration, and Y to be the average area, I guess, is what we're after. Will it let me do that? Well, I go to Insert, I go up here to Scatter Plot, I go down to the dots, and then this is the awful mess that begins to show up. That doesn't look like a calibration curve either, right? So here we get a moment where maybe I have done cal curves, maybe I've highlighted data, I've built graphs around it, it's not a big deal, and then I try to do that here and I can't get it done. Something is wrong, something is off. I'm not doing this the proper way. How on earth am I supposed to build a calibration curve with these numbers separated that way? So in the next video, we're going to go through the motions of how to properly select data when they're not together in a nice little neat format and make a calibration curve. So that way I can generate one on my report before I turn it in.